So I want to use this to go over homework. This was the one about age. I am on the right problem, right? Age and life insurance, yes. All right, so this is another one of those where I said population. What would have been, I didn't write it on here, what would have been our best? This one wasn't as obvious. What could you say is your population?
Users of this life insurance policy.
Anything about like people who could, people who do, people who would use this life insurance policy? I'm looking for exact wording. I don't see it in front of me. Stuff is all out of order. It says something about you had to be over what 40. Oh, here it is. The $1 million life insurance policy of people who are over 40 years old, or at least 40 years old, anything like that. So people who have this $1 million life insurance policy, or people who could have this $1 million life insurance policy. Your X is your age in years. Y is the monthly premium. Depending on how well you wrote your population, this is one that I had written when we didn't write population out that well. So like I kind of defined population within there. So it would be probably your monthly premium. What would our units be in dollars? So my scatter plot should look something like this. And I know that's only 6 points, but you should kind of start to see a curved pattern there. Again, if I've defined my X and I've defined my Y, then I can label it as X and Y. Your residuals plot of X versus Y, make sure you're writing your titles here. I think probably one of the places where people miss the most points on this on a test is people just forget labels. Like they forget to write X and Y and they forget to write scatter plot of X versus Y, that kind of thing. So your residuals plot should definitely have this like U curve to it. At this point, the equation we would have had would have given us negative 300 and Y hat equals negative 342.8 plus 8.6343X. As soon as I write not linear, though, I'll mark that out. So the relationship between, and you could write X and Y there, is not linear. Why is it not? Because the scatter plot shows a curved pattern and the residuals plot follows a distinct curved pattern. So X versus Y is not the line of best fit. Converting my Y to natural log of Y, I end up getting the equation that is natural log of Y hat equals negative 0.0633 plus 0.0859X. That definitely makes my scatter plot of X versus natural log of Y look a whole lot better than my first one. It looks a whole lot more linear. My residuals plot of X versus natural log of Y. Remember, your labels are going to be X versus still residuals just in general. And those look fairly scattered with no pattern. So the relationship between X and natural log of Y is linear. The scatter plot appears fairly linear. The residuals plot, I have to write all three things. Shows no pattern, equally scattered above and below zero for all values of X, and the residuals are relatively small. If I'm talking about the relatively small thing, I don't remember I made a huge point about this in this class. These go to about 0.04 in one direction either way. What am I comparing those to see if they're relatively small? What am I comparing within negative 0.04 and 0.042 to see if they're relatively small? The what? Which general numbers? So in this case, you are not comparing it back to 29, 46, 68, 106, 157, 257 from the original data. You are comparing it. So whatever is here is what you are seeing if these are relatively small related to. So are these numbers relatively small when we're dealing with 3 to 6? Yes. I just want to make sure y'all realized exactly what it is that I was referring to there. So x versus natural log of y is the line of best fit. And if converting just y to natural log of y works, that means our original relationship between x and y is always exponential. Questions?